Okay, we'll go to the next second module flow. First module flow was IDS, IPS, firewall, and honeypot concepts. The second module flow is IDS, IPS, firewall, and honeypot solutions. This section discusses some commercially available solutions that simplify the usage of IDS, IPS, firewalls, and honeypots. So, intrusion detection tools. We have a tool called SNOT. It is an open source IDS, can detect variety of attacks like buffer overflow, stealth port scan, CGI attacks will be seen in details in the web server attack module. SMB probes and OS fingerprints attempt. It can act as a sniffer, logger, IDS, IPS, everything. In the command on the command, just type how to use snort. We'll see. So on the command prompt, you just type snort. Of course, after installing it, I think in the Linux or Parrot, it will come uh, installed. So what are the Snort rules? Snort allows users to write their own rules. However, each of these Snort rules must describe the following: any violation of the security policy of the company that might be a threat to the security of the company's network and other valuable information. All well-known and frequent attempts to exploit the vulnerabilities in the computer network. The conditions in which a user thinks that the network packet is unusual. That is, if the identity of the packet is not authentic. SNART rules written for both protocol analysis and content searching and matching should be robust and flexible. The following two primary principles while writing SNART rules should be followed. No return rule must extend beyond a single line. Thus, rules should be short, precise, and easy to understand. Each rule should be divided into two logical sections: the rule header, the rule options. The rule header contains the rule action, the protocol, the source, and the destination IP addresses, the source and the destination port information, and the classless interdomain routing block. The rule option section includes alert messages in addition to information about the inspected part of the packet to determine whether to take any rule action. So, for example, in this command, if you see, this contains an action which is nothing but alert. Here, the action is alert. Um, the protocol, the next field is protocol, it is ICMP here. And then we have to give the source and the destination IP addresses. So in this example, the source and destination IP addresses are given as any, and then this is the direction. So it is coming into the network, and then source and destination IP address, the source and destination port information. So destination IP address and destination port, here it is home net and any. Destination IP address is home net, port is any. So and then within a parenthesis we give the message to be printed. So in this example, we are printing ICMP ping detected, and SID is the signature ID, some unique number of this kind of alert. Here the alert is about ping from any IP address and any port number. So if there is a ping from any address and any port number to home network to any port, there will be a alert triggered with a message ICMP ping detected. And then we also have a revision. if you do any changes to this alert, then the revision can be incremented. So it's not minus L. Okay, so in this example, after configuring this rule, which is to detect a ping, we'll open the snort by giving the following command. So we give snort uh, on which interface, and the console. We can see the below messages on the console. So from other terminal, we are giving the ping IP address. So when we ping, we can see the below below messages on the console. See, we can see the SID, the IP, ICMP ping detected, from which IP to which IP. The IP address also is shown. Source and destination IP address is also shown. Second example of configuring the rule is for TCP/IP protocol. So here alert TCP any homenet 22 message SSH authentication attempt. So if we receive a TCP message from any IP address or any port to homenet on port 22, port 22 is for SSH, then we will print there will be alert raised with the message SSH authentication attempt. So as shown in the diagram, if on a different network, uh, if we type a command SSH to the IP address where the alert where the snort is configured, where the snort rule is configured, so we can see this message SSH authentication attempt. So we saw action alert for ICMP and TCP. Some of the other examples are log. See here, the action is log, and the source IP address we have given anything that is not equal to 192.168.1.0. CIDR we used for 24. Port also any port. So this indicates double flow on both in and outgoing messages. Other examples, um, again we are using alert here. So here we are checking for the content 000186A5. The message that will be printed will be external mounted access. So here we are giving the port range 1 to 1024. The destination port we are giving a range of ports, not a single port. So in this example, we will log UDP traffic coming from any port and destination ports ranging from 1 to 1024. In this example, so log TCP traffic from any port going to port less than or equal to 5000. So as you can see, before the colon, we have not given any port number, only the uh, maximum port range we have given. There is no minimum port range. Similarly, in the next example, we have given the minimum port range. So here uh, uh, we log the TCP traffic coming from well-known ports, and going to ports greater than or equal to 400. So similar to SNOT, we have another tool called SURICATA. Other tools are Alien Vault, OSSIM, intrusion detector detection tools for mobile devices, ZIPS, Wi-Fi inspector, Wi-Fi intruder detect. Intrusion prevention tools, we have Alien Vault, Unified Security Management, USM, Alien Vault OS SIM is also one of the tools, but that is for IDS. So examples of firewall tools: Zone Alarm Free Firewall 2019, Manage Engine Firewall Analyzer. Examples of firewalls for mobile devices: MobiWall, No Root Firewall, Mobile Privacy Shield, NetPatch Firewall, Honeypot tools, KF sensor. This KF sensor we also saw in the previous module flow. Where did we see this? Yeah, okay. This is an example for low interaction honeypot KF sensor. I think we will see this in the lab also, iLab. Honeypot okay, KF sensor, and then the other example is Spectre. So in the next chapter, we will see evading IDS. So this is a third module flow. So first module flow was IDS, IPS, firewall and honeypot concepts. Second, IDS, IPS, firewall and honeypot solutions. Now we will see evading IDS. In the next video, we will see this.